Alright, my fellow humans, so this is the secret sauce that underlies this entire course. It is called the How to Design Functions recipe, and here are all the steps that it entails. And what we're going to do is we're going to follow these set of steps for every single problem that we'll ever do in this entire course, alright? In this video, I'm going to solve a set of problems in this sort of style, but in the next video, I'm going to go slow motion and explain the rationale behind all these individual steps and why we're doing all of these in the first place. Because I know it seems really verbose, but again, I'll explain that in the next video. But for now, just kick back and relax, try to get the general vibe of things and how things are going to go down, solving problems in this style. All right, so let's get started. So the problem says, design a function that consumes a number and produces twice that number. Call your function double, follow the htdf recipe, leave behind the stub and template. All right, so let's just do that. So first, the recipe calls for writing the signature, so let's do that. So this is how you write the signature, you write the name of the function, and then what it consumes. So it consumes a number and produces a number, all right? Next is the purpose statement. So the purpose is just a one short description of what this function's job is. So your job is to produce twice the given number. All right, there we go. Next is the stub. So the stub is just a dummy function. So let me do that. Double of n is consume one argument because of this, right? And it's going to produce a number. So just make sure that it matches the signature, right? It's just a dummy function that we're going to use to run the examples. So that's step one done. Let's write the examples in step two. So there we go. See, check, expect. If we do double of 2, we should expect 4. If we do double of, check, expect, double of 2.2, we should get 4.4. And let's just do one last one for good measure. Let's see, 5. If we double 5, we should get 10. All right. All right, I'm going to do Control R. You should get a pop-up or something saying this. It says all the tests fail because 0 differs from 4.4, 0 differs from 10, etc. But this is fine. We just want to make sure that the examples run in the first place, all right? Okay, so that is the examples done. Typically, when we're done with this, step 3, we can comment out the stub. So there we go. Okay, gonna hide this for now. And let's move on to the next step. Next is the template, step 3. So let's just do that. So define double of n and dot 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 n. We have to do something to n to get it to this expected value, all right? So that's the template done. I'm gonna comment it out. And then what I'm gonna do is I'm gonna make a copy of that template and then do the next step, all right? So there we go. And now we are on step 4. I'm gonna do the code body. So I'm gonna look at all my previous steps and then see that all we gotta do is just double the number. So this dot 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 is gonna be the times operation. And it's just multiplying the number by 2. And then we're done with this code body, more or less. We gotta make sure that it conforms to all the tests and examples that we wrote. So Control R to run them. And it says that all the tests pass. So that is mostly it for this problem. But the 5th step is test, review, and refactor, and all the previous steps. It looks, for this problem, it's pretty small. So again, it looks pretty good to me. But I will add one caveat here, is that if you have bad indentation like this, right? This is not the style I'm going to write code in, stylistically, like in terms of physical appearance. When I hit Control I, and it'll re-indent and make things look more prettier for you and more digestible for others. All right. So that is it for this problem. All right, so let's move on to the next problem. It says design a function called yell that consumes a string like hello and adds an exclamation point, right, a bang at the end to produce hello bang whilst capitalizing all the letters. All right, so let's start with the steps again. So signature, so yell consumes a string, produces a string. Next is the purpose. So here's an example of a bad purpose statement. It's like consumes string and produces string, right? That just repeats its signature. It's redundant information. It's completely useless and it's not productive. so that we can do better than that. And again, purpose statements are generally hard to write. It might require a second or third revisit, but just do the best you can. So I'm going to do, let me think, produces a capitalized lettered string with appended exclamation point. Okay, that's close enough. Next is the stub, so let's just do that. It's just a dummy function. So define yell takes a string, call it str, takes one argument, and produces a string. All right, there we go. That is done. Step 1. Let me mark myself done for that. Next, let's come up with some examples. Luckily, the problem statement already gave us an example, but that won't always be the case going forward. But we might as well use it and extract information from the problem statement. So if we're given hello, we should produce hello with all caps and then a bang. If we're given by, there we go. We're given by with an exclamation point. All right, so now if we run this function, all the tests fail, but that's fine. At least they ran in the first place. That's all we care about. And there we go. Okay, so now since we're done, let's comment out the stub and let's move on to the next step. We're done with our examples. Let's move on to the template. So the template is define yell str, and we gotta transform str in a way that satisfies our examples. All right, so this is the template. Let's just make a copy of the template and code up the body. So template is done. Let me just give myself a check mark there. All right, so what can we do? Well, first we know we have to add an exclamation point at the end, right? Because that's what the problem statement says. So let's just do that. All right, there we go. Let's just run the test. We're getting one step closer. So expect actual value hello. So this is what we got back. Differs from our tests, right? All right, so we're getting closer, but we got a down case. We got uppercase, I mean, all the letters. So to do that, let's figure out, if are there any functions available in Racket that does that? And you can copy and paste the cheat sheet URL and go to the website. All right, I'm gonna zoom in a little because it's a bit small. All right, so let's find a function that operates on strings. There we go. There we go. You're gonna scroll down. Look for something that takes a string and produces a string. And let's see. In this case, I know that string upcase does what we need, but you might have to scroll and look a little bit more. String upcase takes a string, produces a string like the given one with all letters as uppercase. All right, so that seems to fit. Seems to solve our problem. So let's just use that. All right, so I'm just going to wrap that around here. String upcase. Okay, I'm going to hit Control R. And all of our tests pass. So that is code body done. And then 5, let's review and refactor. Are there anything we need to revisit? Namely, the purpose statement is what you often have to revisit along with the test. But in this case, this is a really small problem. Contrive the example. And that is about it for this one. All right, let's move on to the next one. So for this one, I'm going to make a mistake. Let's see if you can catch it. So design a function called area that consumes the length of one side of a square and produces the given area. All right, so start with signature. Area consumes a number and produces a number. Whoops, number. Gonna make sure we capitalize the type names. All right, next is the purpose statement. So let's see, given side of square, produce the area. All right, of the square. All right, next is the stub. So it consumes one argument. We'll just call it S for side, and it produces a number. We gotta give it a dummy value because that's what the stub is. All right, so that's step 1 done. Let's move on to step 2, examples. So let's see, we're gonna do check, expect, area of 3 is 6, check, expect. So the area of like a 2 by 2 square is 4. That's pretty good. Let's run the test to make sure they actually run in the first place. They do, they fail, but that's fine. There we go. And let's see. Let's move on to the next step. Examples are done. Let's comment out the stub. And let's move on to the template. So define area s. We gotta do something that's s. And yeah, so that's the template done. Move on to the code body. All right, so let's make a copy of this template. There we go. And comment it out. There we go. All right, so let's code the body of this function. So by looking through all my previous steps, let's see. It looks like it's just s times s. That's what that's what the area is defined as of a square in geometry. So you might have to look it up. Some problems require some domain knowledge. So just a heads up, all right? So notice how we use s twice. That's perfectly fine. The template is just to tell you, hey, these are all the parts you have. You got to do something to it. But you can use the parameter as much as you like. 3 times, 4 times, it doesn't matter. But in this case, we know that the geometric definition for the area of a square is just the side length times the side length. That's how much space it occupies, all right? So let's run, make sure all our tests pass. Let's see. Ran 2 tests, 1 of 2 tests failed. So this was the mistake I was talking about earlier. So here we go. It says actual value 9 differs from 6. So let's see. The area of a 3 by 3 square should actually be 9. It's not 6. So the test is wrong. And it happens sometimes. Sometimes you're going too fast or you're just tired and you just write your, the wrong value for the test. No big deal. Go back and fix it. Control run. And all the tests, since both tests pass, completely fine. All right. There we go. And that is the code body done. Test review and refactor. Let's see. Is there anything we want to improve here? I guess we can improve the purpose statement, but this is a pretty small problem for now. Looks pretty good for me. Control I to re-indent. So there we go. Save the problem, and that is it for this one. All right, let's move on to the next problem, image area. So design a function called image area that consumes an image and produces the area of that image. Hence, multiply the image's width by its height. All right, let's get started. So signature is going to be image area, consumes an image and produces a number. So given produces the area of the given image. Okie dokie. So that's the first step almost done. I'm going to write the stub. So image area contains image. We'll say that as the first parameter. And the dummy value is 0. All right. So that's stub done. So just mark myself done for that one. Step 1 is done. Next is the examples. So let's just come up with some image examples. So we'll say a rectangle that is 12 by 12. We'll say solid red. It doesn't really matter these two, but rectangle needs the arguments. That's 144. All right. Expect rectangle. Let's see. Let's do 32 times 32 solid red. That is going to be 1024. Let me just write that out. Cheat a little here. All right. Let's do one last problem. One last. Okay. And let's make it, let me see, 64. All right, 64 by 32. And that is, let me see, times 64, 32, that is 248. All right. And 248. All right. Okay. The colors in the solid doesn't matter, but a rectangle needs it. So let's run it, make sure the test run. And it says rectangle is not defined. Oh, that's because we need to htdf image when working with images. Cool. So now they should at least run and fail, and they do. So here are all the images. Let me see. Actual value differs from 248. What is going on here? Oh, I did not write image area. I gotta feed this rectangle to image area. That's why we have our stub, because I messed up there. But no big deal. let's just fix this really quick. Image area. So now we should get numbers. 0 differs from 154. This is what we want, right? So there we go. Let's just comment that out. We're done with step 1. So step uno, well, step 2 actually. Examples are done and they run. All right, next is the template. So let's see, I'm gonna hide this window for now. So template, the image. See, define image area img, and then let's see, we're gonna do something to the image. All right, that's the template done. Let's just mark ourselves done with that. Next is the code body. So let's make a copy of the template. Again, we'll eventually just delete it entirely, but for now we find that it helps to keep them around. And I'll go into more details as to why, but now let's code the body. So we gotta do something to this image, right? These rectangle images. Let me just copy and show you what they are on the side here. That will calculate their area. And I happen to know that if you use the image, let's see, width, well, image width, yeah, and pass it an image. Image width is a function that takes in an image and gives us back the width. So that's 64, and we will multiply that by its height, right? So let's just do that. So this right here is where you experiment a little, and then when you're done, you can go back here and finish the general formula to satisfy this function. So let's see, we're gonna take the image width, and then we're gonna do the height also. Let's do that really quickly. Height. And then we're gonna multiply them together, and our test should pass, and they do. All 3 tests pass, and it looks like we're kosher. Let's just test, review, and refactor. So it's a pretty small problem. We don't really need to do that. Control I to reindent again, because some people do this. You also space out your arguments, guys, because this is easier to see. All right. So it looks like we're all good. One last thing though, an image area can't be a negative number because a negative rectangle just doesn't make sense, right? A rectangle with negative sides. So we can be more specific here and write natural, right? It's a natural number. Either it's not gonna be negative, it's gonna be 0 through not even 0, it's gonna be 1 through whatever, right? In fact, if we try to make a rectangle with a negative width or something, it's -4 or something, it's probably gonna give us an error. So solid red. There we go. It says rectangle expects a non-negative number. Yeah, because it doesn't make sense, all right? So just heads up, all right? And yeah. All right, so let's move on to the last problem. It says design a function that determines if an image is tall. So notice how this problem statement gives us a lot less information than all the previous problem statements. It doesn't give us the name of this function. That's fine. We can just come up with a name ourselves. And it doesn't really specify what tall is, right? It's really ambiguous. And this is what the htdf recipe helps us with. It helps us tackle problems that are really broad and sort of poorly specified, poorly formed, and ambiguous, and lets us work through them systematically. So let's get started. So signature purpose stub, let's go. Signature, we're going to call this function tall, and we can infer that it consumes an image because it determines if an image is tall. All right, and we're going to say that it produces a Boolean, namely because you're either tall or you're not, and a Boolean encodes those two values just perfectly fine. All right, let's write the purpose next. So it produces true if an image is tall. That's a little bad of a purpose statement. I'll explain why later, and we'll revisit it soon. All right, next is the stub. So define tall question mark, takes in an image, and then produces the Boolean. All right, a dummy value. So by stylistic convention, this language has question marks at the end of functions that produce Booleans. It's just a visual, aesthetic, stylistic thing. It makes it easier to spot functions that produce Booleans, and it also reads pretty nicely. All right, so we're just going to follow that convention. All right, now let's move on to the examples. So we're done with the first step. So examples. So let's use the right side, the here as a sort of playground. So we'll say 6432 solid red. All right. So that's pretty wide. Let's do one where we flip the arguments. There we go. So there we go. And that looks pretty tall. All right, so by playing around, you realize, so that means that the height is bigger than the width, right? That's what we'll define as tall for now. So let's encode these in examples. Tall question mark, let's copy this. There we go. We're going to say you are false because you're more wide than you are tall, right? And let's do one for the true case. All right, there we go. And let's say true. All right, that's more tall. All right, so that's fine. Let's run this to make sure the tests even run in the first place. They do, they fail, but it's fine. All right, so that is that step done. Gonna comment out the stub. Copy and paste. There we go. Examples are done. Let's move on to the template. All right, so that should be pretty quick. So define tall question mark takes it an image. We're going to do something to that image to reach the boolean. All right, so I'm going to copy this. This is going to be the body. Comment out the template. Again, we're going to remove the template in the stub in the future weeks, in the upcoming weeks. And I think it helps beginners in the first couple of weeks, though. And I'll explain why again in the next video. So now let's code the body. Before that, let's revise the purpose statement because we just, came up with a definition of what tall is. So produce true if an image's height is greater than its width. And by doing that, it sort of gives us the answer to the code. So if an image's height, all right, if an image's height is greater than its width, so just, there we go, select these two, greater than, so it's greater than its width, then you are a tall image. Oh. True, otherwise false. All right, so if we run this, both tests pass, but let me show you what happens if you didn't cover one case. Let's say like the false case right here, right? It's going to highlight it in black, and this means that this code path was never lit up, right? It never ran. So that means there's a potential bug that could be lurking, not always, but could be lurking, a potential bug, and you should probably create a test that will run this code path, right? There we go. To cover all spots of the code. Make sure there are no blind spots, all right? But let's run the code. All tests pass, no problem, right? But there is actually a blind spot because we have not considered what happens when the width and the height are equal, all right? Because, say red, right? What happens if it's square? Because we were so focused on tall. We were like, what is tall? Tall, question mark, right? It's greater than its width. Our heads were like solely focused on tall, and we never really considered what happens if they're equal. So this is called an edge case in programming, and it comes up quite frequently because you're just tunnel visioned into one specific problem, one specific way of looking at a problem, and eventually it hits you like when you're in the shower or something. Like, oh, I never considered this case. So you should always add a test for it, all right? And in this case, we're going to say that if you're equal, you're not tall, right? You're just like normal. So this should produce false. And as it does, all three tests pass. So again, we were missing the test. Notice how we had to jump back and revise all the previous steps sometimes, right? It happens. That's what the fifth step is for, test, review, and refactor. So everything looks good now. We have our three cases. All test coverage is fine. We lit up all the code paths. But there's one last thing that we can do to make this cleaner. And let me just show you really quick, like copy and pasting. All right, so this if statement says, if this produces true, produce true. if this produces false, then produce false. But this already produces that, so why are we wrapping it in an if? So let me just do that down at the bottom here. All right. And I'm going to comment this function out there like so and run this. And we should get the same expected value because these two are the exact same, right? And you can explore as to why, but it's kind of hard to sort of explain until you like actually write it out yourself. So we delete that. This produces the exact same behavior. It's just shorter and clearer. So when you're dealing with functions that produce booleans, this is a shorter way. You don't have to wrap it in an if. All right. And yeah. Thank you for watching, human. If you wish to interact with more of your kind, join our Discord linked in the description or on screen. If you want to aid in my quest for world domination, consider hitting the sub button. Thumbs up if you enjoyed it, thumbs down if you didn't. Any questions, comments, or suggestions, fire away below. Also, check out the annotations on screen for the next relevant video.